Good, welcome again in today's video. We want also to look into now grouped data, and this grouped data we want to calculate coefficient of variation, coefficient of skewness. We had already calculated the arithmetic mean, median, mode, and standard deviation and variance in regards to the grouped data. And we had remained with the last two parts of calculating the coefficient of variation and coefficient of skewness. Remember, this question carries, I think, 20 marks. So pay attention, hang on my lips, so that you can understand as we now dive in the illustration. Good. So you realize in the exam scenario, you'll be given how to calculate what? You'll be given such data that you have been given a class and you have been given a frequency. But in case you have been given a raw data that is not arranged in this form, there's a video also in the same which I uploaded on how to arrange this data up to where it is here, how I've been shown here. How you can get the raw data that is just there, and you're needed to go to group them in this form of the class. Regards on how now it will be on your disposal how to come up with the class. Good. So in case you have been given that data, the first thing, calculate, let us fill the frequency distribution table. This is called frequency distribution table. In case you have such data, make sure first you fill this data, this table. So let's fill the data. Here is F, this one means frequency, and this is the class. So cumulative frequency. To get cumulative frequency is very easy. The first value of frequency, put it here as 9. Then the second value, it will be 9 plus 10. Here it will be what? It will be 9 plus 10, it will be 19. 19. Then from there, it will be 19 plus 17. The next value, 19 plus 17. So it will be 19 plus 17. I'll have what? 36. This plus this, it will be here, 36. Then 36 plus 10, it will be 46. 46 plus 5, it will be what? 51. 51 plus 4, it will be 55. Then 55 plus 5, it will be what? 60. Good. That is how we calculate coefficient, cumulative frequency. Cumulative frequency. Good. How do you know that your cumulative frequency is, you have done the right thing? Get the summation of F. Get the summation of F. The total summation of F must be equivalent to the last figure of cumulative frequency. So add 9 plus 10 plus 17 plus 10 plus 5 plus 5 plus 4. You'll get here is what? 60. Use your calculator, because this now will show that you are well. Good. Let's go to the next one. X. X is what? X is the midpoint. X is the midpoint. In this case, X is the midpoint. X is the midpoint. Midpoint of what? Midpoint of the class. You add 65 plus 84, the lower class limit plus the higher class limit, divide by 2. Divide by 2. So the first value there of X will be 74, 74.5, 74.5. The next one will be 94.5. Then the next one will be 114.5, 114.5. Then the next will be 134.5, 134.5. Then next will be 154.5, 154.5. Then next will be 174, 174.5. Then the last one will be 194, 194.5. That is the midpoint. That is the midpoint. Good. The next column is what? Fx. You multiply the frequency, multiply by the midpoint. So it will be 9 multiplied by 74.5. 9 multiplied by 74.5. Here, the first figure here, I will have 70.50. Here I will have 945.00. Here I will have 1946.50. Here I will have 134.1345.00. That is it. Then the other one I will have 772. Really good. So it will be fx. Yes, fx. Good. So it will be here. I will have 72.50. Then here I will have 698.00. Then here I will have 972.50. Good. So that's the fx. Yeah, frequency you multiply by the midpoint, you get the your figure there. Now, after that, you just do now the total summation of fx. The total summation of fx. The total summation, I mean you add the column of fx. So you get the total summation. You get the total summation of fx. So if you add that, you will have 7350.00. 7350.00. Good. Now, let's go to the next column. Next column is x minus mean squared. X minus mean squared. So we have to get x minus mean, then we square. Meaning, we have to calculate mean first. And that is mean, it's arithmetic mean. Mean. We have to calculate first mean. And mean is total summation of fx. You divide by total summation of f. Total summation of f. Mean will be total summation of fx. You divide by total summation of f. So it will be what? It will be total summation of this will be 7,350. You divide by what? You divide by 60. You divide by 60. So our mean will be what? Our mean in that case will come to 122.50. 122.50. That is our mean. Good. So this mean we are determining mean because it's going to help us to calculate the next column. Because our next column requires to get x, we minus mean, then we square. So it will be midpoint, which is midpoint we have here x like 74.5 minus 122.5. So it will be what? It will be what? That one. Then you square it. So if you square it will be now, the first one, it will be x here we have 74.5 minus, okay, let me put this one here, minus 74.5 minus 122.50, then you square. So it will be what? You square. So it will be what? So it will be 2304. The first one here, it will be 2304. 2304. Good. Then next will be 280. 280. It will be, no, it will be 784. 784. 784. Next will be 64. Then next we'll have 144. Next we'll have 1024. Next we'll have 27. 2704. Then next we'll have 51. 5184. 5184. Good. So that is how we have to determine that column. That's why we were determining mean. So mean has helped us to get what? X minus mean, then you square. The way I've done here, the first one here. So you do the rest the same I've done here. Good. So next column is just simple. Now you already have this column x minus mean squared, meaning it will be just frequency f multiplied by that column. The last column, the first column of f, we multiply by the last column of x minus mean squared. So it will be 9 multiplied by 2304. So the first thing here, the first item is supposed to have 2736. That is the first one. Then next will be 7840. Then we'll have 1088. Then we'll have 1440. Good. Then we'll have 5120. Then we'll have 10816. Then the last one we'll have 25920. We'll have 25920. Good. So that is how we fill that table of frequency distribution table. Good. Now, the next part we want to get now the total summation of the last column. The total summation of the last column. And total summation of the last column is you just have to add the totals. So if you get the total summation of this, you want to get the total summation of, you get now the total summation of f in bracket x minus mean squared. X minus mean squared. Good. So we'll go ahead. X minus total summation of that, it will be what? If you add that using your calculator, I think you'll have a 73,960. 73,960. 73,960. Good. Now we have the total summation of the last column. We have the total summation of f, and we have the total summation of fx. Good. So you realize we want what? At the end of the day, you have to calculate coefficient of variation of this data. Coefficient of variation. Now, coefficient of variation, remember we said coefficient of variation is equals to the standard, the sigma, that is the standard deviation. The coefficient of variation, we have to calculate the coefficient of variation, which we said is the sigma. If I use the sigma, this means the standard deviation. You divide by the mean, then you multiply by 100. You multiply by the 100. Now, already we have mean. Already you have calculated mean. So it means we have to calculate the standard deviation. The standard deviation. And to get the standard deviation, remember, the standard deviation, you say it is the square root of total summation of f in bracket x minus mean squared. You divide by the total summation of f. Total summation of f. So you see this one is very much different compared to what we have done initially for the ungrouped data. You realize the other one you are dividing with the total n, which is the number of items you have been given, but this one now is the grouped data, which you have already been grouped together in classes. Now the total of summation of f into bracket x minus x squared you have already calculated, which is here. So it will be just very simple. It's a total summation of that. So it will be 73,960. You divide by what? 73,960. You divide by 60. So it will be what? If you do with your calculator, you'll have your answer as 34.84. 34.84. So that is our standard deviation. 34.84. Good. The other way of calculating the standard deviation, remember we said, is what? If you have the variance. If you have your variance, it's very easy. And variance, we said, just ignore the square root. The variance, you just ignore the square root. And calculate first the total summation of this, divide by this. Then, if you have the variance, it's just simple. You say the standard deviation is equals to the square root of variance. So if I could have just ignored the square root, I get this one first, the answer I could have gotten here, then I could have just squared. I could have just done the square root, and then I could have landed to 34.84. Good. Now we go to our question. The question wanted us to calculate the coefficient of variation. Now we already have the items just to feed in the question. So the coefficient of variation in this case will be what? Will be the standard deviation, which is 34.84. You divide by mean. Mean we already calculated 122.50. You multiply by 100. You multiply by 100%. So what do you have? You will land to your answer as 28.47%. 28.47%. 28.47%. Good. Now, that is coefficient of variation, very easy, and that is how we do that, and you are done. Good. So I wish to do the coefficient of skewness, but I don't know time will allow us, but let's try. The coefficient of skewness is very easy. The coefficient of skewness in this regards will do what? Let me see how I can do this. Because of the space, it will be easier for us. Coefficient of skewness. Okay, good. Let me do it here. Just follow and you'll understand. So the coefficient of skewness, we said we can use the mode, we can use the median to calculate the coefficient of skewness. Let us use the median. The coefficient of skewness in this regards, it will be what? We'll have to, the coefficient of skewness, I will give the formula, then we'll go to, I'll show you how we'll do. So the coefficient of skewness, we said is 3 in bracket, you mean minus median, you divide by what? Standard deviation. Divide by standard deviation. Good. But if you are using mode to calculate, this is Parsons coefficient of correlation. So, but if you are using the mode now, it will be just a mean. It will be just mean minus mode, then you divide by the standard deviation. You divide by the standard deviation. Good. Now, for this case, you'll have to follow on the next video that I'll upload, that I'm going to show you using these formulas on how to calculate the coefficient of skewness. And remember, we said the coefficient of skewness is just a measure, or we compare distribution of a normal data 1. So for today, I wish you all the best. May God be with you wherever you are as you continue following these studies, as we are going to continue simplifying the business and statistics. Bye-bye.